Okay, so now that we've talked about what a rational expression is, you're going to be asked throughout this module and the next to simplify the rational expression. And simplify means a lot of things, right? When we're talking about rational expressions, it means we're simplifying the fraction. You know, think if you would about 3/9. Let's make it simple, right? 3/9 is really 3 over 3 times 3. And anytime you have a rational expression where there's a product in the bottom or the top and you have a similar or an equivalent factor that's being multiplied, we can cancel those, right? So 3/9, when we quote unquote reduce fractions, that's really 3 over 3 times 3. Because this 3 is being multiplied by this 3, I can cancel it with the 3 that's on the top, and we end up with 1/3. So simplifying a rational expression is like simplifying a fraction. Okay, and I don't know how this was taught in elementary and middle schools anymore, simplifying fractions, but it really comes down to prime factorization of a composite number like this, and then finding the common factors that we can cancel. All right, so if you're still with me, simplifying a rational expression takes on the same form. What we want to do is we want to find the prime factorization of the numerator and the denominator. So in other words, factor both of these. Factoring is a huge part of simplifying and working with rational expressions. That's why we covered that first. Okay, so we have an even degree trinomial. An even degree trinomial possibly can be factored into two binomials. We've talked about that already. We know that this first piece, okay, is the product of the first part of each of these binomials. We know that the second piece is the product of these back two numbers. And then these back two numbers have to add to be that. So I think it's pretty obvious at this point, both of these are going to be a +3. All right. On the bottom, again, if you've seen the lessons on factoring and you remember, what do we call this? Starts with a D and ends with difference of squares, right? This is the difference of squares, and the difference of squares will always be factored into, do you remember the C word? Conjugates, right? You're going to hear that a lot. That's not one of these math terms that just gets thrown out and then never talked about again. I talk about this a lot in my class. Conjugates are binomials that look very similar to these, right? Where we have the same thing in the front and the same thing in the back. The difference is one of these gets a plus and one of these gets a minus. Now, when we look at this rational expression in its factored form, okay, we talked about this in a previous video. These binomials, okay, or should I say this entire denominator cannot equal 0. We're not allowed to let that happen. And because this is a product of two terms, right, this times this can't be equal to 0. So if I have two numbers, blank and blank, all right, and their product is 0, what do you know about one of these numbers, right? If the product of two things is 0, then one of these has to be 0, right? I don't know which one, and it doesn't matter, right? Because multiplication is commutative. Either one of these could be 0. Down here, when we relate this to what we're looking at, if we don't want this to equal 0, then this product can't include a 0 in any way. So I don't want this to equal 0, and I don't want this to equal 0, right? So I set up two separate equations, really, and I say, all right, x, when I add 3 here, and I add 3 here, I don't want x to be 3, and I don't want x to be -3, right? Because if I subtract 3 from here and here, I get -3, okay? So these are the exclusions that they talk about. We should look at that after we do the simplifying. It says find all the numbers that must be excluded. 3 and -3 have to be excluded from the domain. We'll talk a little bit more about domain later on, okay? But in order to simplify this now that we have this product, okay, and we had to take a little detour there to talk about excluding those values. So let's look at this again. When something, and I say something, this binomial is touching this binomial, that means this entire piece is being multiplied by this. And when you have a product in your rational expressions, common factors can be canceled. So because we have a product on the bottom and we have a product on the top, and both of these products have x plus 3, that means I can cancel the x plus 3 here with the x plus 3 here. I can't cancel it again, right? up here, I didn't cancel this 3 with that and this 3 with that 3. I only canceled it with one of the 3's that was on the bottom. Same idea here. I can't cancel this x plus 3 with both of these, right? So I'm left with just x plus 3 on the top and x minus 3 on the bottom. And that would be the simplified form of this rational expression.